Welcome back. In this episode, we're diving into how large bodies of air, called air masses, interact to create the weather we fly through every day. We'll explore what air masses are, how they form, and what happens when they meet and form fronts. An air mass is a huge volume of air with relatively uniform temperature and humidity. It can span hundreds or even thousands of kilometers and sit over a region for days or weeks. Air masses are classified based on where they form, source region, and whether they're over land or water. You'll often hear CP, continental polar, cold, dry. MP, maritime polar, cold, moist. CT, continental tropical, hot, dry. MT, maritime tropical, hot, humid. Each one brings distinct weather patterns. For example, a maritime polar, MP, air mass from the North Atlantic brings cool, moist air to Western Europe, clouds, drizzle, and low ceilings. A continental tropical, CT, mass from North Africa, hot and dry, often linked to haze and thermals. These masses move with global wind patterns. When they interact, we get fronts, the boundaries between contrasting air masses. This is where most weather action happens. Let's define a front. A front is a transition zone between two air masses with different densities. It's usually where temperature and humidity change rapidly and where cloud and precipitation systems often form. There are four main types of fronts. Cold front. Warm front. Stationary front. Occluded front. Each has unique properties that affect flight conditions, visibility, and turbulence. Cold fronts occur when cold air pushes into warm air. The denser cold air wedges under the lighter warm air, forcing it upward. This causes rapid cooling, cloud formation, and often cumulus or cumulonimbus clouds. Flying through a cold front, you might encounter showers, gusty winds, and turbulence. Visibility usually improves quickly after the front passes, but wind shifts and pressure drops can be dramatic. Warm fronts are more gradual. Warm air glides over the retreating cold air, forming layered clouds like stratus and nimbostratus. Precipitation is more widespread, but less intense, think steady rain and fog. As a warm front approaches, you'll see high cirrus clouds, followed by altostratus, and eventually low ceilings and drizzle. The risk here is low visibility and long periods of IMC, especially problematic for VFR pilots. A stationary front is when neither air mass is strong enough to move the other. The boundary just sits there, often bringing extended periods of clouds, light rain, or snow, sometimes lasting for days. These are common in transitional seasons like spring or fall, where shifting energy doesn't favor one side. Flying near a stationary front. Expect unpredictable conditions and inconsistent wind. Occluded fronts happen when a cold front catches up with a warm front. The warm air gets lifted off the surface completely. These bring complex cloud systems and sometimes embedded CBS, a risk for IFR flights. There are cold type and warm type occlusions, depending on which cold air mass is more dominant. Either way, expect low ceilings, precipitation, and temperature drops near the surface. Let's look at a cross-section of a front. Cold front, steep slope, fast-moving, short-lived storms. Warm front, shallow slope, slow-moving, prolonged rain. Occluded front, mix of both, with multilayer clouds. This helps you anticipate cloud types and turbulence based on your route. Understanding fronts is key to interpreting weather charts. On surface analysis maps. Cold fronts are shown with blue lines and triangles. Warm fronts with red lines and semicircles. Occluded fronts with purple lines and alternating shapes. Stationary fronts have alternating red-blue lines. As a pilot, always check frontal locations before flight. They influence wind, pressure, icing, and turbulence, directly impacting your fuel burn, routing, and alternate options. Fronts also shift the wind direction. Winds typically veer, clockwise, after a cold front and back, counterclockwise, before one. This affects approach planning, runway selection, and flight level choices. Frontal zones often have temperature inversions. Warm air over cold can trap pollutants and moisture, creating fog, haze, or stratus clouds. Expect poor climb performance and increased stall risk in these layers. Let's imagine a flight from Madrid to Paris. A warm front is passing over central France. METARs show BKN 010, light rain, and 8 degrees Celsius. That's classic warm front weather, low visibility, layered clouds, and potential for airframe icing. Meanwhile, a cold front trails behind. Reports indicate CBS and gusts in the afternoon. You'll want to beat the front, or adjust your arrival time to avoid embedded storms. Another example, a stationary front near the Alps shows snow showers and variable winds. Expect mountain wave turbulence, icing, and low cloud layers, all of which require alternate plans and escape routes. Let's wrap up this first part. Air masses define the general weather you fly in. Fronts are the battle zones where conditions change fast. Each front has its signature cloud, visibility, and wind profile. Recognizing fronts helps you anticipate risks and fly smarter. In the next episode, we'll continue with air masses and fronts, Part 2, focusing on frontal weather hazards, flight planning tips, and how to read charts like a pro. See you in Meteorology number 38, Air Masses and Fronts, Part 2.